Okay, good morning, everyone. First of all, welcome to an event like this. I think it's rare nowadays to do an in-person event. So great to be here. And again, I want to really thank Brian for asking if they can host the event here and making it happen to the entire ClickHouse team. Thank you. I think now it'll be a good applause, I guess. So just a quick intro about me and the team. Again, yeah, I'm Sathish Manivannan. I'm Director of Data Analytics from the Friendly Neighborhood Microsoft WebXT organization. Joining me today is Lin Tang here, Dev Manager, and Narendra Rana, Principal Data Scientist from the org. And we are going to cover like two solutions that we built that are very successful on top of ClickHouse. Let me start with a quick intro of what is the WebXT organization for people those who don't know. So again, WebNext is what WebXT stands for, and it's really like home to some of the biggest web properties for Microsoft, right? Like one is, of course, the Microsoft search engine, which is Bing, which not only powers our first party, plus also powers other search engines like Yahoo, and also is very seamlessly integrated into like Windows, right? You also do file searches. You also can give enterprise content, and we can also search both internet and intranet. Then we have MSN, which is not anymore just about news. So MSN and Bing work very closely to provide super enriching experiences on many verticals, which include like weather, finance, shopping, travel, and whatnot. And all of that, of course, like comes through our big traffic entry point is the browser, which is our first party browser, which is the Edge browser, which is part of the team. And then we have on top of that, where we make money, the Microsoft Ad Network. And then we also have maps and a few other things, right? And really like across all these products put together, our surface area is we touch like close to like 1 billion users in a monthly basis. And data is very staple to how we run the business. In fact, some of the big data infrastructure solutions kind of originated from the team here that went Microsoft wide and even outside. To give you an example, for example, Cosmos, which is our big data infrastructure for Microsoft, the experimentation platform for Microsoft, all kind of originated here. And we not only contribute to the Microsoft technology, we also are very much embracing the open source community, right? So that we can kind of best compete with our fierce competitors. So of course, that's where I think we did strike gold with ClickHouse among other solutions. So that's why I'm very happy to be here, kind of representing two big solutions that the organization built. So one is Titan, which is our internal product for data analytics. So thousands of engineers, program manager, data scientists, marketing inside WebXT and the partners for WebXT across Microsoft, which includes like Windows, Office, and then our global marketing. They all use this product to get time to insights like in seconds in most cases. Then we have an external facing product, which is Microsoft Clarity. That's for website owners to instrument their product to get behavior analytics, right? You exactly get the click-through heat map and whatnot. So we'll go through both details of what these products are and also kind of highlight where ClickHouse helped us and some of the customizations we did around ClickHouse, which we hope is going to be informational for this ClickHouse community. So now let me go a little bit into Titan. So I'll just start with a quick overview of Titan, and then we'll go more into the technical details. So yeah, our vision is like really, take Microsoft mission of empowering every person in the organization to achieve more with data by really making it easy for people to access data in a self-serve fashion, right? So I'll start with a little bit of what is the motivation for Titan. So as I said, like, we have, almost close to 1 billion users, but then a lot of experiments run, like thousands of experiments run every day. Experiments means like A/B tests. You go to Bing, I go to Bing. We may not get the same experience. We may be experimenting something else. And then we have this continuous product lifecycle of planning, experiment, do A/B tests, and then learn and ship. And then post-ship, we track the impact, sometimes for usage, engagement, and then finally business impact. And data is involved across the board, right? So there's quite a lot of data that analysis happened during planning phase. So you see some examples here, right? Like, okay, one team wants to work on, let's say, a vertical called like health, and they want to look at recipes. Somebody will do a query analysis and then look at, oh, okay, people are searching for healthy recipes, and then they'll go and do some experience around that. Or people may look at some user funnel and say, okay, this is our opportunity on Windows, where this is people who use Bing and don't use Bing. And then, of course, you see a click-through heat map that's from Clarity. Where are users really spending time on? And then we can go and optimize things there. And then bottom is where you see some A/B test scorecard, where we run experiments. It could be A, B, C. Like you run a 5%, another 5% you give to one experience and somebody else not the experience, and really look at the impact in a scientific way. And then there are really tools optimized for, like we have a huge experimentation infrastructure in Microsoft, where there's quite a lot of analytics that happen. Then, of course, once you ship it, you really want to know, are we making the impact that we desired? What is the traffic? And then if anything goes wrong, we really want to slice and dice to see, is it which market, which country, which entry point, which data center? And in some cases, we also do long-term analysis, like, are we getting new users or growing engagement of existing users? What does the retention look like? So this is kind of like a glimpse of a few things that we look at. And of course, like prior to Titan, or even now, I would say like there are quite a lot of tools out there. And then we try to see how we can kind of give some cohesive solution, and also is something that everybody can do. So of course, there are data science teams who does some of this, but then they cannot scale for every need, right? So the idea is like, how can we make people do this on an interactive way in a self-serve fashion? That's kind of the big motivation for Titan. Something like a full product lifecycle tool. So then yeah, now let me say what is Titan. Yeah, it's been like 2.5 years now with the product, which is successfully being used. More than like 2,500 people use it on a monthly basis. We get 100,000 queries on a daily basis. And then I also want to give a little bit of history where we actually had other tools. As I said, like we were embracing both first-party and third-party technologies. So almost like, I would say like close to 10 years, like we had Adobe Analytics. We also had Interana, which is called Scuba now. The origins are from Facebook. So we were using all of those tools, which actually worked great, but at the same time, our demands continue to increase, right? So we needed something we can build in-house so that we can kind of innovate faster and keep up with the innovation that the team is doing. So that's why we're happy that we were able to build this tool. And here is a screenshot of Titan. It's like basically on the left side, you see like an interactive query builder where people can formulate the query visually, and then you get user experience here. I'll go through a little more of some of the scenarios there. And what is Titan built on top of, right? ClickHouse is our primary backend. And we also, I would say, hit goal with the front end, which is Superset. So that we also customized it quite heavily. In fact, we did a presentation like this last year to them, and then if you're interested, we can share that as well. There's quite a lot of customization happen there. But ClickHouse plus Superset, backend and front end, this is it. Plus, there are a lot of components. So Lin will go through the architecture of other components, which include both Microsoft and non-Microsoft technologies there. So that is a little bit of, now I'm introducing Titan. And then I'll cover two other things before I give it to Lin. One is, let me talk a little bit more into what are the high-level requirements for Titan, right, that led into some of the actual features. So we at least look at things in these 4 quadrants, right? One is, of course, the top left in this case. So like for a user, right, our key is, first of all, self-serve analytics with response time within seconds. That's our first goal. Like things have to be faster, right? What does that mean? People should be able to get the data and interactively slice and dice. And they don't do it just once. They should be able to save it as dashboards, and then they can look at it on a regular basis. So that is one key requirement. Then we really wanted people to be able to customize it. So it means custom metrics, custom filters, custom columns, and whatnot, right? So that's one. And then it's not about just getting just the data, but also we want to be able to do some advanced analytics, like user analytics. Like, can I create a cohort of users and see users who use health and also recipes? What is the intersection? Can I create a cohort of users, new versus existing, and look at retention over time? And then, as I mentioned, A/B analysis. Can I look at these settings in A versus B, right? So these are some of the key requirements there, right? So we need to be able to have this tool surface all of these key functionality. Then if you look at the other side, data, right? So as I said, like it's Bing, MSN, Edge, ads, maps, and then we also integrate with Windows and Office and whatnot, right? So we should be able to put diverse set of data into the system, and then being able to have flexible data retention. Some you want to store for 15 months, some you want to store for 2 days, and also how fast it's available. Some data we want to be available within 15 minutes latency. So we really need a system that can scale to support these diverse retention needs as well as latency needs. Plus, we also want to have flexibility to be able to do analysis on some high cardinality columns. So for example, we get billions of searches in a month, and also we get billions of actual raw query strings. So one of the common analysis, as I was showing the recipe example, people do free-form analysis of queries containing this keyword. That's a very expensive operation, and we should be able to do that really fast, right? This is on the data side, right? And then of course we know that we are not going to satisfy everybody with like a simple experience or even complex experience. We need to have flexibility for advanced users to do on their own. So we want to be able to have raw SQL access, and also data scientists can connect to Python and notebooks and then do more advanced analysis. So we need to have SQL and programmatic access. And then for all of this, we need an infrastructure that's scalable, performant, and reliable and highly available. So this is kind of what our high-level things are. And then uh, ClickHouse fits a lot of these boxes, right? Definitely it is fast. And we also did some custom optimization. So our main tagline is faster and cheaper, Titan as a whole. But then I think ClickHouse plays a big part in there. And a lot of the diverse set of data needs, we do have to build a lot of other things around it. Like, Lin will talk a little bit about real-time ingestion. But it definitely we are able to have diverse set of data, diverse set of retention needs. And then, yeah, there's a lot of inbuilt telemetry built, so we also can monitor and do many things there. So that's a little bit of a little more details of what are the requirements. Then I'll just kind of quickly end my session with showing you certain screenshots of what Titan looks like. So we have like thousands of dashboards people do for tracking their KPIs. Again, this is where the power of Superset comes. It came with a lot of great visuals. We also added quite a bit of new visuals there. And then again, on the right, you see people really try to do interactive slice and dice. Like this is a custom visual we build where we call it divergent bar graph, which is you can take two different time periods, give a dimension and say what changed. And then that's what you see here on the screen. Then we have user analytics features. Again, we have cohorts, we have retentions, we have user flows. So you can define multi-steps and say users went from A to B to C to D, right? So you can see something like that. And we also have experiences for getting a user funnel. And then lastly, A/B testing. This is still newer. So this is where we complement with our A/B testing infrastructure. So we want to bring all the slice and dice capabilities of Titan to a flight analysis. So you get this big scorecards with thousands of metrics, and then you can come to Titan to slice and dice to see why a particular metric moved. So this is a little bit of intro into Titan. Now, let me invite Lin to talk more about some of the technical details and ClickHouse highlights. Thank you.
Thank you, Sathish. Okay, so my name is Lin Tang, and today I'm going to talk about.
So this is an example of also being able to get access. Sorry. I missed that. There was one more slide. So as I said, like there is also programmatic access. So you can see again, Superset by default gives you a SQL interface. So people can use SQL queries, and also ClickHouse has some good functions, right? Like here's a simple like n-gram distance, like query similarity. So this is a great thing. So you can use ClickHouse functions along with raw SQL. And then the right side is where you see a screenshot of somebody connecting in Python notebooks, and we have to really do some extra work to enable API access for it. Yeah, thanks.
Yeah, this is my slide. So today I will talk about the Titan architecture and some of the optimization we do around the ClickHouse. So this one shows kind of high level architecture looks like. We have data source, engine, the API sitting in the middle, and also the interactive visualization, which powered by Superset. So from data source point of view, we have three main input. The first one we call the Cosmos. This is like a Microsoft internal solution. It's the big data solution, which allows each team to provision like storage and computer resources. It's more run as like a platform as service, which allows teams to kind of store, share, and analysis, and also it's generate insights across a massive data sets. So you can see we have like Bing, MSN, and BYOD is our self-serving features that people bring out their own data set. So a lot of data are coming from these like kind of Cosmos location. Second one is of course like Azure is a Microsoft offering. We have big footprint on Azure. A lot of people are using the ADRS to store data there. Third one is there's a lot of kind of real-time streaming scenario required. People want the real-time data access. So we can ingest data from Kafka or Event Hub and all these places. And second one big piece is the data engine. Of course, like we love ClickHouse. That's why we're sitting here talking about how good like our experience with ClickHouse. So you can see we have multiple clusters set up there. Some clusters are big ones because we have a lot of users like for example, Bing. There's a lot of different data sets they want to come in. Those ClickHouse clusters may have like hundreds of machines sitting there to power a lot of query, like a lot of our interactive queries, which are very pricey queries and very diverse queries we need to support there. And there's also like streaming needs later. I will talk about in my slides is how we solve the real-time kind of like streaming problems. And of course, is like right now we're using Zookeeper for the ClickHouse like cluster management. But we do see some issues with Zookeeper. For example, is like because you can see we have a large amount of data need to ingest into ClickHouse. Sometimes we do see is like when there's a big data try to ingest, the Zookeeper tends to time out. And sometimes it will lock the database, and then the table became like read-only. We are actually testing the new offering is the ClickHouse Keeper, which is pretty good, we can say. So we already run some tests, and we don't see that problem again. Once it's good, we'll start to kind of upgrade this Zookeeper to the ClickHouse Keeper. So really likely ClickHouse able to continue like evolving there. So really thanks here. And the API is the middle layer, is between our backend and the front end. We have MySQL served as our metadata table. So you can have, because it's like we need to run, you can see we have a lot of users coming in, and they're from different org, and they also have different type of kind of data security requirements. So we need to make sure like right people have right access to the data. So a lot of kind of like user access control is like saved in the MySQL. So we know it's like who can have the right access to the data. And ClickHouse does offer the API solution, which is pretty good. But in our case, I mentioned is like we have a variety of front end, like Superset is one. But I think Sathish also mentioned is like we have the kind of Jupyter Notebook, and we also have the Excel and different access coming to access the data. So we actually build an API access layer on top of the current ClickHouse offering. So it has the kind of like sorting because we don't want to have like a bunch of requests coming like flood our backend database, and has like authentication. And in the meanwhile, I think also mentioned there are some like experimentation scenarios. So on top of the data get from ClickHouse, we also need to query like Microsoft internal API, so we can get some like kind of flight details of certain experimentation, and we can get all the parameters there and join with ClickHouse data, and then coming back to the user, and then they can render all the kind of data from whatever the UI they want to. And the query optimizer, this is something I will talk about in the later slides, so I will skip that now. I think caching, you all know how important it is. So like we cannot like afford to have all the query go directly back to our backend database. So we need to have a caching in place. Is like so there's like if there's some query already executed, for example, is like one of the superset functionality is the custom dashboard that I can create a dashboard and share with other people. Then when they open dashboard, they don't need to query the database again. So they can get the data from the caching and then show on the dashboard. And we also have functionality like we know some dashboard people view like every day. So during the kind of like low load time, we can pre-cache the data. So when morning they come in, they can see the data right away from their dashboard. Last piece is the visualization part. I think Sathish mentioned this is the superset UI that we use. This is built on, I think, Airbnb open source this functionality. So I don't want to talk a lot about here since Sathish already showed a lot of kind of slides around how we do there. We did a talk in superset community about how we customize superset. So if people are interested, we can share the link. And there's a lot of discussion around this, like how we do query builder and how we do this visualization, all the customization we do in the supersets. And also there's a bunch of platform features we built. One thing I want to call out is the sampling. There's different scenarios coming to Titan. If some just want to do, for example, it's like year-over-year analysis. So in that case, it's year-over-year, at least like 13 months of data they need to query against. But if you try to query that against like raw data, that's huge, and it's like the cost is really high. And based on our analysis, most of the time is like sampled and unsampled data returns pretty similar results. So in those cases, like they usually kind of query sampled data. But there's also like experimentation scenarios, like we need to calculate all the metrics there. And in that case, is like people really care is, hey, what's my metrics movement? Like 1% or 0.1% is very important. So in that case, is like raw data is kind of the requirement, so I have to query along. So we provide a kind of like both for people to easily switch. On the superset UI, actually there's a toggle and they can switch, and we also upscale. So if we know they based on 5% sample data, and we upscale like 20 times, so they will see it's like, for example, the monthly active user will be very similar as they query the full data set. So we have all that mentioned on UI. Yeah, I think that's pretty much for the Titan architecture. So next I will share some optimization we do around the ClickHouse. So talk about near real-time pipeline and some query optimization and the storage efficiency. Okay, this shows the near real-time data pipeline. So first I want to talk about is like why near real-time is important for WebXT business. One thing I want to mention is like our business is most like an online business, and we call it's like zero cost to switch business. What does that really mean is like, say if you are on some internet provider, you use it and you're not happy. It could be slow, or maybe the network is not stable, or maybe the customer service is bad, and you want to switch. There is a cost to switch because they have to investigate, hey, what are the potential options there, and what's the cost? I have to pick up the phone and call the old one and switch to the new one. There's some work related there. But for our online service, it's totally different story. So like you can imagine a user go to Bing.com, type a search query. If he's not happy with the result, maybe 1 second later, he could be on Google and type the same search query. And maybe we lost that user forever. So that's why for us, have real-time data access to understand is like what's overall our service is doing, how user is interact with our service is super critical and for us. That's why we have this kind of requirement. Hey, how can we build this kind of near real-time pipeline to collect all the signals from our production service and allow our engineers to analyze the data like within minutes? So this is a very hard problem to solve. And we previously using kind of like internal solution, as Sathish also mentioned before, but that one was really pricey. Even for license fee, we need to pay like millions of dollars to build that. I'm very happy is the ClickHouse is able to kind of provide this real-time kind of data ingestion, and once the data is in, and I can query right away. So this is a really nice feature, like we're able to leverage it here. And another one is you can see all this infrastructure are built based on the Microsoft and Azure offering. So first talk about the scale here. So we have this production server. So you can think about use Bing as an example. Bing is a global offering, so it has data centers like across the world, and we have like thousands of servers kind of serving production traffic. And for all the servers, they may generate like billions of events like every minute, every hour. And for users, like our engineers, need to kind of have access to those data and do this analysis. So there you can see the amount of data we need to handle and to ingest. We know like ClickHouse do not like small files like keep on getting ingested into the cluster. It's actually like big files. So in that case, that's we use like Azure Append Blob. It has a really nice kind of like features. Is like it can allow like multiple servers like writing to the same file at the same time. So in that case, like we don't need to generate thousands of small files, so we can combine all the data into like one big blob file, and we can generate several, and then keep that ingest into the ClickHouse. So Azure Function is the one that we use to monitor the kind of the Azure Append Blob once the file is ready, and then we write the message into the Azure queue. That's our ingestion queue. And on individual ClickHouse machines, we actually have ingesting service set up there. And this one, we call it like a worker node ingestion because the amount of data we need to download. So thinking about it is like every second, there will be a couple gig of data we need to download and ingest. So those ingesting servers can think about it like we're reading the message from the queue and see, oh, this file is ready, and download to the machine, and then ingest. And once the ingester is ready, and then user can query from the front end. We also have this catch-up queue. It's like when we need to do like backfill, or maybe sometimes there's files, some corrupt or some issues, and then we can backfill, and it will go through central ingestion. We did some prototype with like a central ingestion for all the files, but the throughput is not able to meet our requirements, so that's why we do this the work node ingestion. So with everything all this setup, like user able to do the kind of like real-time data analysis like within minutes, like after the event is generated from the server across the world. Okay, next one is the dynamic query optimization. So I think in the architecture diagram, we talk about is we have the ClickHouse as a backend and the superset at the front end. The API kind of sitting in the middle. This reason is like, if you can see, is like this is our query builder. So you can see like a user can put their queries there, unlike the typical like scenarios, you write your own query, you like select ABC from table and do all these things. We don't require user have very rich kind of like SQL like experience. All they need to do is, hey, this is a matrix, could be predefined, or they can create their own matrix. What's the time range? What I want to group by, or maybe I have interest in certain market or certain data center, and they can generate a query there. Just kind of input there, and the superset will kind of like convert that input into a query. But you could imagine that the query is not fully optimized. If we use it as is and send to the ClickHouse, it could run, it will give us result. But it's like if we keep on having this kind of query flooding to ClickHouse, it will impact our performance. So that's why we kind of build a query optimizer in between. And we have this kind, because we understand what kind of data coming and what are the query pattern they have, then we can build kind of corresponding like optimizers for each type of query. So there are a couple examples shows there. One is the joiner optimizer. So we know like there's one thing that I wish like ClickHouse could do better is the joiner support. It's like, because it's all local machines, if you do big data join, it's always a challenge and kind of slow down the performance as well. So you can see for this particular example is like experimentation scenarios. There are a couple metrics that people want to care about. For one scenario here is like, if you go to Bing.com, if you search Seattle weather, maybe always says raining. But there will be say, hey, if people search a weather-related query, and when weather card shows up, is like, what's my kind of click-through rate, or what's the interaction there, how long they stayed on the page. So these are the metrics that people will care about. And if we just calculate as is, then you can see you have matrix 1, matrix 2, and calculate on individual machine. And then like once all the results come in, and there's will maybe like a master node, and then do all the data join, and then return the results. That's slow. So in our case, is like we actually build an optimizer there. So we know is, hey, for this particular scenario, we know it's always based on the weather card being triggered. So rather than I do all this join at the end, can I do at an individual machine? So we convert this full data join to the local join, and we join on individual machine. Then on the master node, then I just need to do a merge, which is much, much faster compared with the kind of like the global join. So in that case, just with this optimize, I think this particular one give us like 10 times kind of like query improvement. Another one here is the condition optimizer. If you see, is like this screenshot may not show that, but user can add different conditions, and by default it will show up like these inline conditions, like the red box here. So this one is a super inefficient way of doing kind of like the where select query, because you actually manipulate a lot of data. So rather than doing this, it's one easy fix is, hey, you know, what if I do a where first? Then I can pre-select this, pre-apply these conditions to significantly reduce the data size, and then I do this, will be much faster. So this is also another optimization we do. Third one, I didn't put a screenshot here, is like, we know is like, because we have users across the world, and there are requirements around, hey, you know, some data set is based on the UTC, some based on PST, different time zone, you know, we all have this kind of challenge. And when user put there, yes, you can use the timestamp, say, you know, from PST time, it's like, and do with all these shifts and calculate there. But this actually slow. We are not able to fully utilize our index. So for those kind of scenario, we also have a kind of like a time zone optimizer, and we can also add another filter, select the date range first, and then apply the timestamp, and which we also see a big improvement from the query performance. So, okay, next one, storage efficiency. Yeah, this is something I think like one thing we hear a lot is like do more with less, right? So there's a lot as like we deal with the kind of database thing, we always have in mind is like, hey, how can we save the data efficiently to improve the storage efficiency? In the meanwhile, it's kind of save the overall capacity cost. So these are a couple of things we do in Titan. So first one is the string into conversion. So this pretty simple, like intuitive. Yeah, string is a very high cost item. If you save in the store, if you save in the database, then a lot of storage. Int is definitely much smaller. One example here is like, I also use Bing as example, is like if you go to Bing, search Seattle Seahawks. So first thing you will see is maybe a sports card. Shows like last Saturday was the Seahawks throw with 49ers. And we lose there. That's bad. But there may be some videos, show some clips. It's like what's the highlights of the game. And then maybe another card, some factor card shows what Seattle Seahawks is, like who's the quarterback, whatever. And there's some images there. So you can see just one single query. There could be like multiple answers get triggered, like sports answer, image answer, video answer, like fact answer, whatever, or the list of answers there. And for the engineers, when they try to analyze data, this information is super important because they want to know is like when their feature answer get triggered. So like a news team and the weather team, they may care about different things, but both have the same requirement is like, hey, you know, when this query coming, how's the answer triggered? And so this is a very popular kind of column people query a lot in the database. So you can see one way is we saving as a array, string array. So it's like weather answer, fact answer, whatever. It's like super long and super costly to kind of deal with. So what we do is we actually like kind of convert all these strings into int. And another thing we do there is you can think about we have UI, right? And from UI point of view is you don't want to use it, say, if answer 1 is triggered, what does that really mean? So users still need to see actually the string value, say weather answer, or maybe like what the fact answer, or maybe sports answer. So what we do is like in the MySQL, we actually save a kind of like a mapping table that people like when they come in query, they will still search the kind of sports answer, but when the query go to the query optimizer, it will query our MySQL and get the mapping table, knows, okay, this particular answer mapped to this particular int number, and then convert that to the kind of like our backend database. So this is one thing we do just for one of the data set, after we did this kind of string into conversion, we're able to save about like 60% of the overall kind of storage. Second one is the column-based retention, right? So one thing I really like ClickHouse is it has a very rich kind of telemetry information, and we are able to get all the kind of like each column, what's the size used that, and also for the query, we also can get to kind of what are the query people issued, how many time, how the duration of the query, and all this information. So based on that, we can create a kind of dashboard like this. And for each column, we can see what's the overall storage used and what's the usage pattern there. And then we can easily identify is, hey, what are the columns that people use a lot that we definitely want to keep? But there are some columns with very high storage costs. But in the meanwhile, not query a lot like the one highlighted here. Maybe it's a very good candidate to either cut the retention rather than say 13 months. Maybe 1 month is enough. Or maybe we can just kind of delete this column. So this is very helpful information for our kind of like the column-based retention. Next one is table and row-based retention. So table is pretty straightforward. It's like each user has different requirements. Some just want 30 days data. Like for real time, maybe I don't need like 1 year of data. Maybe 30 days data is enough. And there's users want to year analysis, that's 30 months. So we can easily set a TTL at the table level, and then it will automatically delete the data once it's reached the time. And the second one is the row-based retention. So as you know, there's a lot of requirements coming in. Is, hey, GDPR, like when user come in, say, hey, they go to Bing, say, hey, I want to delete my account, I want to delete all my information. We will need to, from backend, is also delete all the user-related data within certain days, maybe 30 days or whatever the law requires there. Microsoft really treat this like as important, as a very important kind of user scenario. So our product needs to be kind of GDPR kind of compliant. That's also what we do in Titan as well. It's like once we get this kind of deletion signal from the user, we do the role-based we do this role-based deletion, so we know is that what needs to be deleted and keep on tracking the deleted. So we do all this work there. Last one is the LC4 and the CSTD. This is another thing I was saying. ClickHouse is having this kind of like rich kind of like encoding options for us to pick. So this table is kind of published online, shows the benchmark result between different kind of like encoding methods. CSTD has a really high compression ratio, but of course there's like, if you see the encoding and decoding speed is definitely kind of a little bit slower compared with default LC4. When we first set up ClickHouse, we were just using the default LC4. But after we did some testing, we find out there is a slightly kind of performance penalty when we switch to CSTD. But overall, it's actually for some table, I remember, it's giving us like about 50% of saving once we switch to CSTD. And the performance is like ingesting a little bit slower, and the overall query performance is manageable. So that's why we did all the switch.